Let's say if we want to find out the solutions to the equation sine of x is equal to root 2 over 2. And I want to find out all the solutions to this equation. Now, before doing this, you need to know an important trig identity, which is sine of x is equal to sine of pi minus x. So this is basically kind of the visualization for it. And I will do an algebraic proof just to show you that these two things are equal to each other. But basically, okay. So let's say if we have an angle x right over here. This is angle x. And this is what the ray kind of looks like. This is what the ray looks like for angle x. Okay. So remember back to like your unit circle, right? When you have a unit circle, when you have like a point on the unit circle, you can draw a ray to, cross through that point, and it's going to create an angle, right? And the coordinates of this point is cosine of theta, so cosine of the angle that you created, comma sine of the angle that you created. So in other words, cosine represents the x value of this point, and sine represents the y value of our point. Now, when you create sine of pi minus x, so this angle right over here, so this big angle right over here represents pi minus x, the angle pi minus x. Well, all that's basically doing, you can imagine this y-axis as like sort of like a mirror. And imagine if we reflect this ray across the y-axis. Well, what are we going to get? We're going to get this ray right over here. And notice how this ray right over here has the same y value as this ray right over here, right? They both have the same y values. The x values of these 2 points are different, right? As you can clearly see, right? One is positive, one is negative, but the y values of these points are the same, right? So this is why sine of x is equal to sine of pi minus x. It's because when you create this angle x, right, you're going to have a y value here. But when you create the angle pi minus x, all that's doing is it's just reflecting this ray to the other quadrant. So in this case, my ray's in the first quadrant. What the angle pi minus x does is it reflects this ray to the second quadrant, but still, notice how like the shape of this ray didn't like change, right? The ray didn't look like this, right? When you reflect across the y-axis, it still kind of maintains its shape. So the y value is going to be the same, right? The y value is going to be the same, but the x value is going to be different. So this is why sine of x is equal to sine of pi minus x. And to do this algebraically, when you have sine of a plus b, this is going to be equal to sine of a times cosine of b. If you don't want to see this, you just want to skip right into the how to solve this equation, then go do so. But I'm just showing you kind of the proof for it. So when you have sine of a plus b, so when you have sine of one angle plus another angle, it's going to be equal to sine of a times cosine of b plus cosine of a times sine of b. And this is the same for when you have, and this is basically the same formula for when you have sine of a minus b. When you have sine of a minus b, this is just going to be equal to sine of a times cosine of b minus cosine of a times sine of b. Okay, so using this, I can plug sine of pi minus x into this formula right over here. So sine of pi minus x. All right, so now notice how I have sine of pi minus x here, right? And it's in the form of sine of a minus b, where a represents pi, a is equal to pi, and b is equal to, in this case, x. B is equal to x. So I could just substitute that all into my formula. So sine of a minus b, in this case pi minus x. So sine of pi and minus x, that's going to be equal to sine of a, so sine of pi, times cosine of b, so cosine of x, minus cosine of a, so cosine of pi, and then sine of b, so sine of x. Okay, now let's do some stuff. So sine of pi is going to be, what's sine of pi? Sine of pi is going to be equal to 0. And 0 times cosine of x is just 0. So all of this cancels out. Cosine of pi is equal to -1. -1 times -1 gives me positive, right? Two negatives make a positive. So we're just left with 1 times sine of x, which just gives me sine of x. So yeah, that's the proof for it. It shows how sine of negative x, sine of pi minus x is equal to sine of x. So in this case, I have sine of x is equal to root 2 over 2. This is basically asking us, this question is basically asking us, at what angle is our sine value, aka our y value? So at what angle is our y value equal to root 2 over 2? What angle is this? Now to solve this, first of all, you have to memorize your unit circle. All right, so that's one thing. So if you haven't memorized it yet, you should probably review on that. But our angle, the angle for this solution, so in this case, actually let me do this. So it's angle x in this case, right? Because we're trying to solve for x, not theta. So sorry, I wrote that. But so in this case, the angle that makes the y value equal to root 2 over 2 is pi over 4, right? You can plug this into your calculator. Sine of pi over 4 gives you root 2 over 2. Now, using this new formula, well, if we know that x is equal to pi over 4, then sine of pi over 4, so sine of pi over 4, has to also be equal to sine of pi minus pi over 4, right? Using this formula that we just learned. So in this case, we have sine of 3 pi over 4. All right. So sine of 3 pi over 4 is another solution to this equation. And I mean, you can kind of see why. So to kind of visualize it here, right? In this case, we're trying to find out, like at what y value, at what angle. So at what angle is our y value equal to root 2 over 2? And notice how there's two answers, right? There can be one answer here, but there can also be another answer here where the y value is still root 2 over 2, right? And this angle right over here is just going to be angle pi minus x, right? It seems like we got this two solutions to this equation. X is equal to pi over 4 and x is equal to 3 pi over 4, right? But wait, there's one more thing I got to talk to you about. You remember this trig property? Sine of x is equal to sine of x plus 2 pi. Okay? What the hell does this mean? Well, imagine this, right? So let me do this in this color. So let's say, right, we have our angle right over here, and it hits this unit circle at this point. In this case, it's root 2 over 2. Well, it turns out that there's actually infinitely many solutions to this equation, because what we can do is we can keep going on in a 360 around the unit circle, aka adding 2 pi. Right? So basically what I'm going to do is I can keep on adding 2 pi. I can keep on adding 2 pi around this unit circle, right? I can keep on looping around this unit circle, right, by adding 2 pi. And notice how I still get the same angle value, right? I still get the same ray, which still hits this unit circle at this point. So technically it's still a solution, right? And you can do this infinitely amount of times. So in fact, what we actually do is rewrite 2 pi n to the n of our equation, to the n of this. So our solutions to this equation are x is equal to pi over 4 plus 2 pi n, where n is an integer. So n is an integer. And we have x is equal to 3 pi over 4 plus 2 pi n. All right, all this 2 pi n is doing is we're just going to keep on looping around the unit circle. That's what this 2 pi n means, okay? Plug in n is equal to 1, right? We get 3 pi over 4 plus just 2 pi. If we plug in n is equal to 2, we get 3 pi over 4 plus, if n is equal to 2, then 2 times 2 gives us 4 pi, right? And notice how we're just going in multiples of 2 pi around the unit circle. Also, you can also visualize this, right? Like this. If we have sine of x here, then we have square root of 2 pi, right? And then we're getting another solution, right? For this point right over here, right, we're going another 2 pi, and then we're getting a new solution, right? So we can go 2 pi infinitely many times around the unit circle. So we're just going to keep on getting infinitely many solutions for this.